All right, let's see if that's working. Okay. Grab the chat window. About. Where'd you go? There you are. Okay. So, last time we worked on day 5, part 2. I did the pretty naive approach of just map, a billion numbers, and it took quite a long time. Made the fan spin up on my laptop, but it did finish in about 7 minutes. I later thought of, I later learned of a couple of other strategies, one of which would be to just take a look at the ranges, see where the ranges overlap, and where they don't overlap, you can create new ranges to fill in the gaps. Because if, say, you had a index of 1 and there wasn't a map that covered 1, well, then you just need to use 1 in the end. And so you could end up creating maps of ranges that have everything, and that would have made this a lot faster. In fact, milliseconds fast rather than 7 minutes. But this is one of the fun things about Advent of Code, is sometimes you do things the terrible way, but still works, and we're going to move on. Okay, so I've been trying to avoid all of the other people who are farther than ahead of me, but we'll see how far we get tonight. I have about 1 hour. All right, the ferry quickly brings you across Island Island. After asking around, you discover there's indeed normally a pile of sand. Somewhere near here, you don't see anything. As you try to figure out what to do next, you notice a poster on the wall near the ferry dock. Boat races open to the public. Grand prize is an all-expense paid trip to Desert Island. Okay, so we've got to win a boat race. As part of signing up, you get a sheet of paper, your puzzle input that lists the time allowed for each race and also the best distance ever recorded in that race. To guarantee you win the grand prize, you need to make sure you go farther in each race than the current record holder. The organizer brings you over to the area where the boat races are held. The boats are much smaller than you expected. They're actually toy boats, each with a big button on top. Holding down the button charges the boat. Releasing the button allows it to move. Boats move faster if their button was held longer. But time spent holding the button counts against the total race time. You can only hold the button at the start of the race. The boats don't move until the button is released. For example, time 7, distance 9, time 15, distance 40. Okay, the first race lasts 7 milliseconds. The record distance of this race is 9 millimeters. Okay, the second race lasts 15 milliseconds. The record distance is 40 millimeters. The third race lasts 30 milliseconds. The record distance in this race is 200 millimeters. Your toy boat, I love how they did this because they know people are going to say this out loud on stream, toy boat, and if you keep saying it, well, yeah. Your toy boat has a starting speed of 0 millimeters per second. For each whole millisecond you spend at the beginning of the race, the button speed increases by 1 millimeter per second. So, because the first race lasts 7 milliseconds, you only have a few options. Don't hold the button at all, and it will travel 0. If you hold it for 1, then the boat will travel at a speed of 1 millimeter per millisecond for 6 milliseconds, reaching a total distance traveled of 6 millimeters. Let's see. Okay, so when the race starts, you can hold the button for 1 millisecond, and then you would travel 6. Well, we can't do that. You hold the button for 2, giving your boat a speed of 2 millimeters per second, or millisecond. It will then get 5 milliseconds to move, reaching a total of 10 millimeters. Hold it for 3, you get to 12. Holding it for 4, you'll only have 3 milliseconds remaining. You'll also get to 12. So we basically have a curve that we need to fit the best into. Okay, since the record is 9, there are actually 4 different ways you could win. You could hold it for 2, 3, 4, or 5 at the start of the race. In the second race, you could hold the button for at least 4 milliseconds and at most 11. In the third race, okay. To see how much margin of error you have, examine the number of ways you can beat the record in each race in this example. Okay. So let's grab our example input and we'll just start by parsing. So I'm going to go out of here. Let's make our prompt a little bit smaller. I really need to make a shortcut for this. Okay, so then we're going to do cargo new day 6. And we'll open up day 6, close that one. All right, so main.rs is going to be renamed to lib.rs. And we are going to make a bin folder that's not in source. How do I do that? Goodness. There we go. I want to make sure that that's what I wanted to do. Now I'm forgetting. Let's open up our terminal, and we're going to do that, and then day 5. Oh, bin was inside of there. My bad. Let's make a new file for part1.rs. We're going to take all this stuff, move it into here. All right, so this becomes pub mod part 1, and then we'll also have a pub mod part 2. So let's duplicate this guy. Well, let's make it work first. So this one is going to say part 1. We will use day 6. Part 1 and the process method, which we don't have yet. So let's make that inside of here. That will be part 1, not in there, in here. Make that return a string. This will return format. And we will just do that. Part 1 will call let input equals nothing for now. Process the input, stuff the result in there. Okay. So then I can duplicate this for part 2. Well, let's just leave it, and I'll get rid of that for now. Okay, so now I'm in here. I should be able to do cargo build. I also started using just in the previous example. And the just file is an easy way for me to watch a given test. So if I do just watch part 1, that means I need a part 1 test. So let's add that test. And I also noticed that you don't necessarily have to put your tests in a separate module. Typically you would say mod tests and then only include it there, but this may be just a little bit simpler. So we'll test our sample input here. We are going to add cargo add nom and indoc. Indoc so that we can do indoc like that and have a nicer formatted string without needing the leading characters like that. Okay, so this one gets imported. I have to cargo build. Okay. Then we're going to assert equals that the process function returned 288. Process input. Okay. Just watch part 1. Now we can use indoc here. Well, supposed to be able to use indoc. Okay, so we only got our input out, we didn't get the 288. So let's start with that. We are going to start by parsing the times and the distances. So maybe I'm gonna have a struct of each race, and then here we'll have a time, which will be a U32, and a distance, which will be a U32. We're going to derive debug on that. And then here I want a function to parse the races. So the fun part about this one is that our time is on one line and the races are on the other. So I think I would parse that out in 2 arrays and just map or zip the arrays. I think that would be the easiest way. So if I do function parse races on some input string slice, so that should give me a vec of race. Okay, so we're going to take the input. The input is going to be 2 lines. So we're going to have a separated pair, separated list, separated pair. So there's 2 items. There's the first line, then the second line with the separator of line ending, and then the second one. This one is going to be a preceded one with a tag of time colon space, and I need to peek at the input. So the input is always just that. That's it, time and distances. I think that's the shortest input I've ever seen. Okay, so time, and that is multiple white space. So this is going to be preceded space 1. It's probably a better way to do this. Let me start importing these. Nom character complete space 1. Import tag. Nom complete tag, terminated, sequence terminated, and preceded, nom sequence preceded. Okay, so this one is a separated pair that has all of this input eaten up. Then we have a terminated list with this as the first part, and then the second part is a separated list with at least 1 element, and spaces are the separator there. So then this is going to be a complete U32. Okay, so this is part 1, and then part 2 is this one, which is basically the same thing, but instead of time we have distance, I believe. Yeah, time and distance. I'm going to copy that and add that as our input.text, just so that we have it. Okay, we're going to need line ending. No. Line ending, like that. Import it. Then we have complete nom character complete. Okay, so in the very end of this is actually going to return an I result with a string slice and then a vec of race. So we can import nom I results. All right, so let's first test. I'm going to duplicate this whole test and just make sure that we can parse out Well, this isn't returning the right thing. So this is going to return an input, which we don't care about, any remaining input. Then we're going to have a tuple of vex of U32. I believe, will that compile? All right, so for our second test here, we're going to do test parse race. I'm just going to say parse race times maybe, just so we have separate tests. So here we're going to say let input is that, let races be parse races on the input. The result here, I'm going to unwrap it and grab the first element, which will be the vec of races. And then here I'm going to assume that this is going to be a vec of 7, 15, and 30. And that's going to be process input. Sorry, that's going to be races dot dot map r, and that's going to be r dot times. And then I'll collect that so that we can compare with the vec. Okay. Vec of race is not an iter, which is true. All right, we're going to collect into a vec of U32s, which hopefully it'll figure out. Generic arguments here. This is true. This needs to be times and distances, which I think it should figure out here. Then I would return times.zip distances. Then we're going to map the result of those, and we'll get a TND which now can give me a race of time and distance, which if I do it like this, time and dist, then I can just pass in time dist. And then I think I need to collect that at the very end. All right, let me put the map on its own line so we can read it a little better. Now, what is the problem? Terminated tag time. I think maybe I grabbed the wrong tag again. I thought it was nom complete tag. Yeah, I think it's this one. Which one did I have? I did have complete tag. That only has tag. Yeah, I ran into this on day 5 as well. Let's take a look at day 5. Source part 1. Let's take a look at what I did here. Bytes complete tag. So let's get rid of that. I'm gonna have to remember that for next time. Okay, line 26. Yes. Unused import indoc, which is used right here. Preceded. This function takes 2 arguments. I think I wanted that. Then the terminated. And then the same thing here, which puts that like that. Unclosed delimiter is here. That's terminated. This one is that terminated. Oh, that's not right. I don't think this one should be here. I did need that. Okay, preceded is argument 1 for terminated. And let me make this on multiple lines. Okay. This one is preceded by that one, then follows this one. Then I need that here. And I think I need the same thing here. Terminated, preceded with only one, and then another one here. Pretty sure that's what I need. And then line 17 terminated takes 2 arguments, but only one was given. I don't think I need that one, actually. We've got a separated pair. The first one is preceded by this one, and then this one. Yeah, I think that I had one too many. And now I can't find indoc. Use indoc. Indoc. Unused import. I'm not sure about that. Expected opaque type found. So I can't figure this out. If I give it a real type of string and a tuple of vec u32, vec u32, mismatch types expected due to this. This is one thing that I'm struggling with Nom a little bit, is sort of trying to figure out what the output should be. All right, so I'm gonna Separated pair, you take one thing, then a tag, then another thing. So that's the parser. It'll take an ABC, a tag, and an EFG, and we get back a result of the tuple of those two things. That seems right. Separated pair by the first thing, then a line ending, then the next thing. The first thing preceded by time and space, then a separated list 1, and that one we give it the separator first, followed by the element, and it returns a vec. Is there a different error that I can look at? No, I don't think so. Actually, this does help. Why is it returning a vec of references? Oh, yeah, I don't think I can do that. And yeah, I can't do that either. All right. So if I added a U32 reference, let's take a look here. Separated list 1. In this case, it's returning a string slice, so I guess it may make sense. But we also get a problem here. And then when I do it like this, now I find... Okay. If I did this and this, still is confused. We can probably split this up into the first part and then the second part. So let's say we do... now I know why. I need to actually call this with the input and do question mark to fail. Okay, that's what it was. I have made that mistake twice now. Here, I need to dereference it. U32 cannot be dereferenced. Do I clone it? Time.clone. Dis.clone. This probably would have been easier just splitting strings. This whole thing needs to return an OK. With the remaining input. So I actually do need the input here. This needs to be a tuple with input and then the results here. Okay. Enum variant takes one argument. It's true because this needs to be a tuple. Time and dist are never read. Okay, so now parse erase time has worked. Let's also look at parse distance. So this one should be dist, and then we will take a look at 94200. And that worked. Okay, so the next thing to do is then to process this function. We get the input, and we should be able to get the races, which is parse races from that input. We will expect that this works, and then take the first element. Now we have the races. We can do an impl race, and then let's say we do best hold time. So this distance is the record. And the race time is this much. Okay, so hold times to distance, something like that. I think maybe I could do this, and then this would return a vec of, no, this would return a hash map of U32, U32. And then we would have to do a, this would take self. Actually, isn't really, yeah, this one would take self, and then we could take another function that would be so what I'm thinking is we do a range from 0, which doesn't make sense. So we would do 1 up to and not including the race time. And then that could give us a duration that we hold the button. That will give us a duration that we hold the button. We have the distance from self. So at this point we would say the speed that we would get is the duration that we held the button, milliseconds, and then times however many milliseconds we have left. So this would be self.distance minus duration of holding the time. And I think we can just do this in line. So that gives us a map of all the times. I don't think we need a hash map. I think we just need a vec of tuples. Okay. So then we do hold times to distance. When we process the results, we can say, or what are we looking for again? 4 different ways you could win. You could hold the button for 2, 3, 4, or 5. In the second race, you could do this. The number of ways you can beat the record in each race. Okay, so for each race, let's map that, and we can get the race's distance, hold times to distance. We're going to filter the let's see, this one maps and gives us, this doesn't give us a vec of 2 items. This gives us the 1 item. So we need that to be, this is our time and this is our hold time. So if we hold it for 1 second or 1 millisecond, then we have this result. Got it. Okay. I assume that we're going to need that number later. So here, hold times to distance filter, this will give us the hold time and our finish time. And then we want the finish time. We don't care about the hold time right now. If the finish time is greater than, if it is greater than this race's distance. No, this race's distance. Finish distance, not time. Okay. And then in this case, we care about the length of this. Okay, and then at the very end of it all, these are all the number of times that we can beat the distance. And then here we want to fold that into one, where the function takes the result and the count, and we do count times r. Let result equals this. Unclosed delimiter for this one. Yeah. Vec_race is not an iterator. One day I will remember that. I think I want count, not len. We can borrow r here, which would be fine because we're just doing a simple comparison. Self.time, yes, that's correct. And the fold at the very end, I need a semicolon. Okay, and test sample input failed because we are not actually returning the result. So here, instead of the input, I'm going to pass in the result. And we get a lot more than we thought. Okay, so let's start by debugging this hold times to distance for each one, because it looks like that is wrong. So we should have 3 of these. The first one, sorry, not here, running 3 tests, part 1.rs. Line 23. How are we calling that multiple times? Oh, it's running it multi-threaded, so our output is interleaved. Okay, so in the first example, if we look at our test here, no, not there, in our sample input, we have 7 milliseconds, and the record is 9. We know we parsed the races correctly. So if we start with 1 millisecond, then we have 8 remaining seconds, 8 remaining milliseconds in the race, and we go 1 per. That's fine. This one, if we do 2, then we go 14. If we go 3, we go 18. 4 gives us 20, 5 gives us 20, and then we start going down again. 6 gives us 18. And that is the end of that first one. So in the first one, we get, this one does not pass, this one does, so that's 1, 2, 3, 4, 5. Oh, and then we can include the number because... No, we can't. Because if we held for 6 milliseconds, that means there's 1 millisecond left in the race. This is wrong. Let's start with the first one. If we held for 1, there's 8 milliseconds left in the race. that makes sense. If we held for 2, then that means there are 7 milliseconds left in the race, and 7 times 2 is 14. This one ends up being 6 times 3. This one is 5 times 4. This one is 4 times 5. This one is 3 times 6. Yeah, I think that I am... So duration is right. I think I did that wrong. I need time in here. Yeah, this isn't distance, this is time minus duration. That's why. Okay, test passed there. Don't have much time, but I can at least read part 2. Oh wait, we didn't run it on our sample input. Let's do that. On our real input, rather. Include stir, input text. Just run part 1. Cargo in part 1. Okay. As the race is about to start, you realize a piece of paper, the race and times got a very bad kerning. There's actually only one race. Ignore the spaces between the numbers on each line. Now instead it means this. Now you have to figure out how many of the ways are into the single race. Okay. We can do that. So let's duplicate this. Part 2. This will be part 2. Part 2. Duplicate this. Part 2. Then lib needs to add that. Okay, so now when we do this, we should get a single race. This should be, rather than a separated list, I think I would want to I'm not quite sure how I would do this. If I did times dot map t, and I mapped that to a formatted string t, and then I joined that. Let's do just watch part 2. So then we would get a times string. Times.iter.map. Can't find joined. Let's look at that. Join. But this one needs to be on iterator. If I got rid of this whole thing, and just say, give me anything, alpha, numeric, or a space. I do take until, maybe this is easier. String list.join with a separator. Not joined, join. That method not found, and this is because it's this should be a map of strings. It doesn't have to be a vec, does it? There is a join in iter tools. Let's cargo add iter tools. Use iter tools join. Okay, just watch part 2. Okay, so it ran this time. So now the question is, now that I have this time string, I have joined it, then I should be able to say replace space. Oh wait, there's multiple white space. Well, yeah, it wouldn't matter. If I replace any space with that, then that gives me the single time, and then I can parse that. So then this would be time would be a U32. It might be bigger, actually. We'll find out. Okay, and dot replace needs to be changed there. Okay, it's running again. Where's my debug code? I want to get rid of this. Okay, so we have the same exact code for the distance. This is going to be D, then dist stir, which gives me the dist. And then I can return the race of time and dist, which needs the OK with input and then this, which means that now we don't need any of that stuff, which means I need to change the return type to just be an I result of a single race. And now 84 needs to be changed. Parse race times. This should be a single race. We're going to assert equal race.time is equal to 71530. And then we're going to do race.dist should be 940200. Okay, let's just get rid of that. Test parse race. Okay, where do I have iter.races? That's in here. Okay, so now I just need a single one, and then the answer is how many ways can you beat this race? Which ends up just being the count, so I can delete that. Just say race, which is this guy. Race, hold times, filter out these, that becomes race. Dot count. We don't need to multiply anymore. And I think that we're done. I don't know where that came from. Don't need it. Take till, yeah. Let's get rid of, remove unused imports. Okay, distster. Times and distances. This should be distances. Did it tell me what the sample input would be on part 2? In this example, the race lasts 71530. 30. Did I make a mistake? 71530. 71530. 71530. What did I do wrong here? How did I get 7503? Race time. So the left is wrong. Oh, I'm looking at the wrong thing entirely. That's this one. Oh, it was correct. Wow, those numbers are too similar. Okay, so now if I run it on part 2, connect on line 55. Overflow. So let's use 64-bit integers here. And here. And that means the race also. And here. And then here and here. All right, let's try it. Okay, sweet. And only 2 minutes over. All right, thanks for watching, and I'll see you again in the next one.